Salam Doctor, I'm Siah Yih Hoong, and today I'm going to present about Lab 2 generation of amplitude modulations. So at first, we're going to look at the first task we're given, which is we're going to generate an amplitude modulation signals. So we already given the variables, which the carrier frequency is equal to 5 kHz, the amplitude carrier signal is equal to 9 volt, the sampling time is 10 milliseconds, the modulating frequency is 500 Hz, and amplitude modulating signals is 4.5 volt. So we are required to use MATLAB to generate this amplitude modulation signal. So let us take a look on MATLAB. So in MATLAB, we need to call out all variables first. For example, like we need to call out the frequency, the amplitude of the signal we're going to generate. So for example, I want to create or generate my carrier signal. So I need to list out all the variables or call out all the variables. And then after that, we need to define the time instant for my graph. So for example, that this line of code is actually telling us from 0 to this value, we will have 500 of data, which means from 0 to this value, which is 0.01, we will have 500 data, and this will make our graph become smoother. And if we don't want to write this code, we can actually write this code also. Both of them give the same function, just that this won't measure, this won't separate those data automatically. So we need to calculate by our own. And after that, we need to generate the signal by using a sine function. And this formula is actually from the sine function, which means Vmax and then sine WP. And W is omega, and omega is equal to 2 multiplied by pi multiplied by the frequency. After that, this subplot is actually means that we need to pick a place for our graph to put. For example, subplot 3, 1, 1. This means we will have a 3 by 1 dimension of table, and the 1 is the place that we want to place our graph. So there will be 3 rows and 1 column, and we will place this carrier signal in the first place of the table. And after that, we will plot the graph and also add the titles, the labels for the x-axis and the labels for the y-axis. And in here, I have already made my titles for my carrier signal as carrier signal, and the label for x-axis is time, and the label for y-axis is voltage. And after that, we need to generate our modulating signal. So the things is same, which we need to generate or call out our variables, generate the signal by a sine function, which from the formulas of amplitude multiplied by sine omega t, and omega is equal to 2 pi f. And then we will need to place our graph into the second place of the 3 by 1 dimension tables, and then we plot it, and then we add the title, we add the x label, and add the y label. So for the modulation signal, since we have our EM and EC, which is the amplitude from the carrier signal and the amplitude from the modulating signal, and we will have the index modulations, and then we will bring this into our modulation signal, which having this formula, and then we place the graph into the third place of 3 by 1 dimension tables, and then we plot it, and we add the title, we add the x-axis, we add the y-axis, and then generate. So as we can see that this is the graph generated by the MATLAB. And then I can show you that this 500 here is telling us we will have 500 of data through this graph. You can see the dotted, right? So this means from 0 to 0.01, I will have 500 of data. So if I replace the 500 with any numbers such as 200, our curve will not so smooth. Yeah, so the larger the number, the smoother the graph is. Yeah, and the larger the number of the data. Okay, so this is a carrier signal, the graph of the carrier signal. This is the graph of the modulating signal. This is the graph of the amplitude modulation signal. So you can see that the y-axis for this tree graph is voltage, and the x-axis is time in second as well. So for the second example, we need to generate the AM wave, which is the same things. So in MATLAB, we still need to do the same things, which we need to call out this variable first. So we will have the modulating wave as a sinusoidal wave. And then the modulating frequency will have 1 kilohertz, the carrier frequency will have 20 kilohertz, and we will have the percentage modulations 75%. So at first, we need to define our time instant from 0 to this value, 0.01, we will have 5,000 of value. And then we need to define the variables. Okay, this is the frequency, this is also the frequency. This frequency is the carrier frequency, and this frequency is the modulating frequency. And this is the amplitude of the wave. And this is the percentage modulation, but in decimals. After that, we will fit these variables into this signal. This signals is come from the formula. Yeah. And then we need to plot our graph inside like that. And then we add the titles, and then we label the, our x-axis and y-axis. And after that, we just need to hit the run button. And this is our graphs. So from here to here, we will have a lot of signal, which is 5,000 of signal, is it? Yeah, 5,000 of signal from 0 to 0.01. 0 to 0.01, right? And then this is the voltage. We pick right here, and this is time domain. Yeah. So let us get into example 3. So example 3 will be example 3 will be generate this amplitude modulation signal. Yeah. So we are given the carrier frequency as 10 kilohertz, amplitude carrier signal as 2 volt, and sampling time as 10 millisecond, modulating frequency as 2 kilohertz, and amplitude modulating signal as 1 volt. And then we still need to do the same things. At first, we need to define our time instant from the minimum time to the maximum time, which is 0.01, and then the time step, which is the time intervals of the graphs, and then we will plot this graph. This means that from Tmin, this Tmin, and Tmax, the Tmax, we will have this amount of intervals right here. And after defining the time instant, we will define our variables, the frequency, the amplitude, all of it. And then we need to calculate, generate our signal for modulating signals and generating the carrier signals, and then our amplitude modulating signals. After that, we need to plot. And you can see that this phrase is special. Like, how to say, in a previous example, we don't have this hold on and off state. But never mind, I will explain it later. And then after that, we will need to add our title, X labels, and Y labels. So what is the hold on status and hold off status? The hold on status is actually to let us retain our plot in the current axis so that the new plots added to the axis do not delete the existing plot, which means we can annotate our plots in the current axis. And then the hold off set the whole state to off so that the new plot added to the axis clear existing plot and reset all axis properties. So after that, we need to hit the run button. And this is our perfect graph. How sweet it is. So from 0 to 1, we will have this amount time intervals, and then so this code is actually telling us the upper envelope, which means the graph at the green color layer. Okay, right here. This is upper envelope, and this is the lower envelope. So this graph is called as envelope because the graph is inside the upper envelope and the lower envelope. Yeah. So this is my presentation, and thanks for your patience to listen to my presentation. Thank you.